All right, so welcome everyone. I'm super happy to be here. It's not always that you get to chat about VEX with such a knowledgeable audience, so thank you for being here. My name is Adolfo Garcia. I usually go everywhere by Puerco, so if you see that little piggy saying dumb stuff, it's me. I am one of the Kubernetes release managers, and I'm also one of the technical leads with Kubernetes SIG release. We work on the release tooling that cuts the Kubernetes releases every month. But mostly related to this talk, I'm also one of the technical leads of OpenVEX in the OpenSSF and also the protobom project. I sometimes do contributions to SPDX, the S1 format, and I maintain probably too many S1 tools. So always help wanted to all of the open source projects. And I'm also like a cyclist. And yeah, for work, I work at Stacklok, and Stacklok is a new startup created by one of the Kubernetes co-creators and Luke Hans, who created Sixer. And we try to help developers do better decisions when they ingest dependencies. So the goal with this talk is to try to give you an idea where we see OpenVEX working inside of the whole supply chain, not just in a company, but taking into account how information should flow from open source all the way down into the enterprise. My goal is to give you an idea that improving information and transparency of how a vulnerability impacts software benefits open source maintainers, but also the enterprise. So I hope I'm super interested in hearing everyone's takes at the end. So don't hold off on any spicy questions that you may have. I get offended easily, but I hide it, so it's okay. All right, so let's begin with a few cases. So this is my introduction. I tried to picture what could have the most impact. So I'm going to focus on bogus CVs opened against open source projects, and also how those affect everybody downstream. So here's a good one. This is one of the CVs opened against Postgres, where, according to the maintainers, the report claims that a denial of service, I think, can be caused by sending a SIG hub by a privileged user to the Postgres daemon, which is, in other words, how things are supposed to work, right? If you have the superpowers, you may be able to restart the server. Here's another fun one. This is about the Caddy web server. The Caddy project received this issue in the repositories, saying that there's a panic that can be caused by an out-of-bounds write to an array, basically. And the maintainers took a look at it and said, okay, yeah, we found it. You can actually, we saw where it's happening. And on top, at hold, the maintainer says, okay, I acknowledge this is a bug and it should be fixed in this patch. And the next response is, okay, this issue has been assigned a CV number. And you can see here the frowning icon from the maintainers, the disappointment. And my favorite comment is the one highlighted there, where the maintainer says, well, the only possibility of this bug is DDoSing the attacker himself, which is fun. But nevertheless, this got assigned a CV number with a score of 7.5. This is a really good comment explaining how, well, the vulnerability only, there's no attack surface because you have to misconfigure the server and lots of other things to trigger the bug. And finally, my favorite warrior of bogus CVs. I don't know if you know Daniel Stenberg, the maintainer and creator of curl. He has been very vocal about especially the burden that bogus CVs cause to open source maintainers. And if you haven't read this post, it's like super recommended reading, where he explains how, well, basically the story is at some point, curl received on their mailing list notification that a new CV was filed against curl. And if you can see, the CV number is 2020, but this was filed almost 4 years later, based on the issue. So they went back and they found out that this was based on an issue that was 4 years old. Someone, and if you see the GitHub user, it's like only became active to do that and disappeared again. and I guess my guess is that it's people wanting to have a CV in their name. I don't know the motivation, but in the end, it got filed as a CV. Now you may be thinking, well, is there much trouble with this? And the answer it is. So if you think about it, curl is probably one of the most, if not, well, yeah, one of the most, probably the most used utility. I don't know. Well, one of the most utilities of open source. So what happens when curl gets like a CV filed against it? Well, everything starts flowing down from there. So the first one is you have the packagers of curl that ingest that and package that software version. So those those also are marked as compromised. And then those system packages flow into things like container images, which in turn get also flagged as being vulnerable, because if you scan them, the scanner is going to find those vulnerabilities. And the same thing for the library. So curl also has libcurl, which is a library which is used in many, many other projects. So what happens when curl gets that vulnerability? Well, the library becomes flagged, and also the binaries. And those binaries can also flow into other derivative works and software projects that also become marked as vulnerable. So meanwhile, everybody using downstream open source in the enterprise has to get their security teams, their application security teams, and to triage that vulnerability. And then DevOps teams start patching and then working. So this is a lot of time wasted for everybody, not just the maintainers, but also for the enterprise. But you think about one case is like wasteful enough, but while we wait for this to build, there's also, you have to think that this is happening at every level of the supply chain, because all of those dependencies are flagged as vulnerable. So this is why we want to VEX, because we want to, if you think about this information, the reason that everybody got flagged as vulnerable was because the scanners were pointing and reading from databases that had no input from the maintainers. So what we want to do with OpenVEX is to enable the flow of information about impact from the people who are probably the most qualified to do the assessments, the maintainers themselves. So this is the brief introduction for VEX. So just who is familiar with VEX? Okay, so I have an introduction, but I'm just gonna rush through it. So VEX, the Vulnerability Exploitability Exchange, is a chronological system of statements. And I want to be very clear about that chronological system, because it's statement after statement that conveys information of how a vulnerability impacts a given piece of software. Those statements are contained in one or more documents, and it can work very well with SBOM, but it can also work independently. And it is coordinated by the VEX working group, which our friends at CISA facilitate. We have meetings every Monday. And there are 4 major implementations. We're going to talk about them in a little bit. What we know about VEX is captured in this document, the minimum requirements for vulnerability exploitability exchange, a document that was drafted by the community. It has like, I don't know, 20, 30 people signing it. Everybody got to have an input on the way VEX was designed, because the community in VEX is very, very diverse. So the views I'm going to express here about VEX are for a particular way of looking at how you match particularly vulnerabilities to software. I know we had some interesting discussions yesterday about how CSAF sees things. But this is, everybody got to have their input into the document. And the working group is chaired by one of my favorite people in the world, Art. So if you see him, big thanks. And these are the 4 VEX implementations. We have CSAF, the Common Security Advisory Framework, CycloneDX, SPDX, which just had their RC2 release, has a VEX implementation in it, and OpenVEX. So how does VEX work? Well, it's a sequence of statements. And a statement pairs 3 basic things with a timestamp. The first one, the vulnerability, the product, and the status. So I'm going to show here, this is a skeleton of an OpenVEX document. Probably you cannot read it, but it's okay. I just wanted to show how those things get crammed in there. So the first one is the vulnerability. We identify vulnerabilities by the identifier string. The identifier string can be anything that you can use to track that vulnerability in a database. And most importantly, the idea is that your VEX processor, be it a scanner or other security tool, can locate that vulnerability in a database. OpenVEX supports aliases of those vulnerabilities because sometimes one same flaw is listed in many databases. The second one is the product. OpenVEX works with product identifiers. And by product identifiers, we don't mean the CSAF product, the notion of product. We are actually working at the level of artifacts. So we want to not address a product or a product family. We want to target specific artifacts, things that you may be able to identify with a hash, for example. The identifiers, so OpenVEX is based on JSON-LD, and the reason why we build it that way is because we want to link to other documents. OpenVEX is supposed to be independent of SBOM formats, so we were looking for a format that lets us point to the documents in internal elements in other documents. So basically, the identifier field in OpenVEX can take anything that it's a URI. So URLs, CycloneDX URNs, all fit in there. And of course, package URLs can fit in there as well. Finally, there's the VEX status. The VEX status is what gives you the information of how the vulnerability affects the software. Those are the 4 VEX statuses: affected, under investigation, not affected, or fixed. Some of them may require additional information. So for example, when you're not affected, you have to add a justification informing why that's the case. In this case, it's inline mitigations already exist, which basically means I already patched it or added some other protection. And finally, the timestamp. The timestamp is really important because it's what lets you know where in the sequence that statement fits. We're going to see a deeper example. So as I mentioned, you have a statement, and then when you have more information and you have more knowledge about the impact, you issue a next statement and a new statement. Then the last one becomes the last known, the effective VEX statement. So we're going to dive now into what OpenVEX does. So the first thing to know about OpenVEX is VEX is the implementation. OpenVEX is a VEX implementation that's incubated inside of the OpenSSF. OpenVEX is designed to be super lightweight, do only VEX, nothing more. And it's designed to be both embeddable, so you can inject OpenVEX information inside of other formats, for example, attestations. And it's designed to be easily attestable. But the most important part is the OpenVEX project goes far beyond being just a specification. So capturing things in JSON is a problem, but it's not the hardest problem that VEX has. So as long as we are expressing the information according to the minimal elements of VEX that the community defined, we really don't care much about the JSON. I mean, we do offer guarantees and stability on the format, but what we're mostly interested in is fixing and solving the other projects that hinder the adoption of VEX. So this is why we offer a series of tools. This one is a screenshot. I had a demo, but I couldn't connect my laptop, so sorry. So this is a screenshot of VEXCTL, which is the main tool that OpenVEX maintains. This is a demo just creating a document. So you do VEXCTL create, pass it the product, the status, and all that, and it'll spit that. VEXCTL offers other capabilities like merging documents, querying them, signing them, creating attestations from them. And well, we're trying to build as many features as we can. And all of those, as I was mentioning on this slide, are exposed to other projects, to other software projects that need to do VEX as libraries. And the libraries handle all sorts of things that VEX agents need to do, like VEX processors need to do. So we handle the document handling, so you can write and merge them, so you can find the last, the effective statements. We also handle all of the signing and converting those documents into attestations. And we do the signing of those documents with SIGSOR. We also handle, and I think this is very important, we also do the identifier matching. So when you have package URLs and things like that, the OpenVEX libraries will do the matching for you. And the reason why we want to handle this is because we don't want to have like diverging interpretations of how we match things, especially because we overload or abuse a little bit the package URL schema, because we will sometimes use, for example, versionless package URLs to specify things like any version of this package. Because it's, well, once you start vexing, you can see how, oh, this will never be affected. So I need to express that. Then we also manage SBOM like ingesting and parsing. And the new feature is the discovery of documents. We're going to talk about that in a little bit. And the next upcoming project is the trust framework. OpenVEX, some of the maintainers are also working with the scanners. So we currently have support in Trivi and Gripe. They natively can ingest the OpenVEX documents. I've been pestering my Sneak friends as much as I can to get them to adopt it. When they see me in conferences, they run. So if anybody knows anybody, please let them know that I'm looking for them. So the next question, can I VEX? And this is a topic that got into the VEX working group. I don't know, we discussed that for like 4 months or something. And the reason is everybody may have a reason to VEX. So what do I mean when I say that anybody can VEX? So think about this. The first people who should be able to VEX are the software authors. As an author, I have the most deep knowledge of how a vulnerability impacts my software. So I should be able to issue VEX documents. The next one is the packagers. You'll often find, for example, the Linux distributions backporting patches or just patching things by themselves before upstreaming those patches and effectively neutralizing vulnerabilities. While the version may match, the security issue is not longer there. Then there's the automated tools that do reachability analysis. So some companies already doing this on projects. Edgebit and Cubescape are already doing that automatic finding of so they will look at the running workload, see what it access or not, and then give you an assessment that a vulnerability may not impact you and issue a VEX document about that. Then there's security researchers. Security researchers in the like, for example, third-party researchers looking at code or auditors looking at your code may be able to issue those VEX documents to complement the information. And finally, there's the application security teams inside of companies. They may also issue internal VEX documents to control how the scanner will see their software. So with that in mind, what we want to see is a scenario where we can create a very rich history of VEX, starting with open source, but that doesn't stop at open source. Let me give you how we see this. So for this example, I'm going to use as the VEX product a container image there. And that container image has a vulnerable, well, a version of curl, specifically the Debian package curl. So below there, I want you to keep paying attention of how the VEX status keeps changing as more information becomes available. So this is going to be the VEX history of our product there, of the container image. Now keep in mind that VEX has a product, in this case, the container image, and has subcomponents, which is curl in this case. We have the image, that's a product, and then contains the curl. So the first thing that happens to initialize a VEX history is some researcher may find a vulnerability. So they take a look at curl, they found that vulnerability, and they say, okay, this may be a security issue. I'm publishing that. It doesn't really start a VEX history until that vulnerability gets assigned a public identifier that especially the VEX processors, scanners, and other tools can find. So while the researchers may not really issue a VEX history, they're kind of starting one. But until that vulnerability finds its way into NVD or other databases, it becomes part of my VEX history. The VEX history may be non-existent because it's just a vulnerability in my piece of software, so it's implied that I'm affected. So the next one is maybe the curl project, and Daniel says, "Oh, I see that there's a new CD issue," like going back to the previous issue, that the false positive that we saw. I see that there's an issue. Okay, let me take a look at that. So assuming that curl starts a VEX history of their own, Daniel would issue a document saying that this is under investigation. Now, the important part here is that I have a VEX history for my container image, and there's like an orthogonal VEX history for curl. And right now, the Daniel statement, signified by this here, hasn't made its way down there. And what needs to happen for that statement to make it to my VEX history? Well, there needs to come a VEX processor, in this case, a scanner. And until that scanner can find that statement from Daniel, then it can assemble together with the information from the vulnerability database and the statement from Daniel. It can assemble the VEX history. So once the scanner processor looks at it, it can piece everything together, and now we changed the impact statement, the status to under investigation. So the idea here is that VEX processors should find those documents without any human intervention. So what we want to make sure is that VEX processors look at a piece of software and say, "Oh, I know where to find your VEX information. Go to the internet, fetch it, and assemble everything." There's a lot of challenges for that, and we're going to talk about the missing pieces in a little bit. So remember that we are talking about the Debian version of curl, right? So next thing that happens, Debian may look at the statements that are upstream and see, okay, I have one statement from the researcher and I have one from the maintainer that's under investigation. What do I decide? So the project may have policies or weights to say, okay, I'm going to consider the maintainer's statement and incorporate the under investigation. So you now our VEX history now has affected, under investigation. The effective one is under investigation because it's the last one that we saw. And then Daniel looks at the vulnerability, and in this case, he says, "Okay, I looked at it, and it's indeed affects curl." So what he's going to do is he's going to issue a new affected statement, which is going to append to his VEX history of curl, and then my VEX processor, in theory, should be able to locate that last statement. And what happens is that Daniel moves to the end of the VEX history and becomes the affected, the effective status. And then let's assume that Debian haven't yet issued a release for that version of curl. They may be able to issue a patch, and then they issue a not affected statement, and it moves to the end of the VEX history, and the effective statement becomes not affected. Now, if you look closely, you'll see here that I have two affected statements, one on top of the other. And the reason why I added those two is because we're trying and experimenting with ways of building those VEX histories by capturing information flowing from other VEX histories into one flow. But what we want to have is proof of inclusion of those statements from other people. So the idea is, if when Daniel here says it's affected and the researcher says it's affected, I want to see those in the Debian history because it makes it stronger. And you also have to consider that adding or removing statements could be a security issue, because in the end, when we have a full working VEX system, that thing is going to be able to turn or activate scanners and maybe releasing software into the wild that may not be. So we want to build those security guarantees. It's not there yet. I'm going to talk about the future projects. So well, this was about that. So the idea is you capture those. And then my VEX history, like I left this out for simplicity, but the idea is that I would have a rich VEX history for my container image, capturing all of those statements, so that I can explain where the information came from. So it's a little bit, if you think about it, it's a little bit like a Git merge commit, where you have a commit that points you to existing history of other things. This is all. There's no working code today for this. Only experiments on my old laptop, but this is where it's going. And finally, well, this is probably where the open source history ends, but it doesn't need to end there for users of the artifacts. So if there are consumers using that piece of software, there may be times when you simply don't agree with the VEX history that you're seeing in front of you. And that doesn't prevent tools like Kubescape issuing VEX documents. For example, it may be the case that you run that container image, Kubescape looks at the running workload, and it finds like, oh, that patch didn't quite work because I'm seeing that a vulnerability being reached. So Kubescape may be able to issue a new document, which is internal for the company, and you have that preventing that container from launching. Or the other is security teams may decide that whenever you see one kind of justification for being not affected, for example, they may issue policy preventing those workloads. So all of that can be controlled inside of the enterprise by using internal VEX documents. All of this history, the idea is that our tools will be able to piece it all together so that you don't have to worry about merging documents or finding the latest or any of that. So if you just to recap here, what you're seeing here is you have the VEX history from curl, which is different from the VEX history of the Debian curl, but all of those two converge into my product, which is the image, and have statements from that. And so to enable some of this work, we're trying to do, we're starting to build the OpenVEX discovery module. And the way it works is there are two main use cases. The first one is I have an artifact that has already VEX information published. I feed that to the security, to the discovery module, and by using its identifiers, hashes, package URLs, things like that, the idea is that it can go, if it's a container image, it can look inside of the registries to find existing VEX information, and like it will read it for you, verify the signatures. Now, the signatures that we have today are only signing the document. We don't have anything about trust. This is one of the upcoming work, some of the upcoming work. The one that's under development and I was going to demo today is a Git discovery module. So the idea is if I have an artifact and I know its Git repository, which is easier said than done, I can go look into that repository and read the VEX information. We are experimenting this with some of the Kubernetes projects, and looks like it's working well. And finally, the last one is we're going to be able, the other one that we're building is looking into the GitHub artifacts to retrieve any existing VEX information published with releases, which is kind of janky, but it's another repository. And the second use case is when paired with an SBOM. So as I mentioned before, finding the repository is not a trivial, like if you get like a blob, how do you know what the repository was filled from? So for that, you have SBOMs, and I'm being like politically correct here, listing both. And so under the hood, OpenVEX uses protobom. So it doesn't care which format it's using to read the SBOMs, and it can be more than one SBOM. It will combine the information, and then it'll find all of the components. And by using the same discovery module, it can go, and by reading hints of the repositories from the SBOM, it can go and do all of those lookups to find the information. And finally, there's the work that we are planning and slowly starting. As an open source project, things can always benefit from more maintainers and people helping. So hint, hint. So the first one is more discovery plugins. One of the great things of being here is that we can talk and I can understand how people are planning to use VEX, whether they're planning to publish it. And we would like to write as many plugins for discovery as we can. The next one is a trust framework, right? And the trust framework is basically answers a few basic questions. Like, for example, in my example before, how do I know that Daniel Stenberg is authorized to release VEX statements for curl? It should be able to tell me that. Not only that, but how do I write policy that tells me that if there's a VEX document coming from this project, from this person, I will allow it to flow into my VEX history? That's the kind of questions that the trust framework is going to answer for people. Then the database backend. This is a really important one because all of our demos are cute little thingies with a few documents, but things start to scale up really, really fast. So as you start like getting information from the dependencies, the amount of data starts like getting bigger and bigger, and we need to have a bigger database story behind it. Then the always ongoing work, adding support for more scanners. So if anybody here is from some scanning kind of company, project, whatever, and wants to have VEX, especially OpenVEX support, I would love to chat, and maybe we can start collaborating. And finally, one of the things that we've been thinking is if the project could at some point, host some kind of public service to aid and make discovery more efficient. There are some ideas around this. One is a VEX hub where people can upload VEX documents or not. Another idea is having a sort of proxy like the Go language uses, like you ask it and it has pre-cached copies of all the data that you need, things like that. But those require people on call, money, and all the things that open source projects do not come across easily. I mean, we are fortunate that we're under the OpenSSF, so we may be able to ask support, but we need to figure out if this is needed. In order to build the last stages of this future work, we need to find signals that we need them, because I don't want to be on call for a project that no one uses. And well, finally, the call for participation. OpenVEX is a open source project. This is not like a freemium kind of open source. Like there's no commercial interest behind this. Anybody can use it. And so this is some of the links that we have. That's the main repository. We have meetings every other Monday on the OpenSSF. We have a channel called the OpenVEX, at least for now. And yeah, I mean, I'm Puerco almost everywhere. And if you would like to join the project or chat more about it, I'm happy to always discuss VEX things. And yeah, so that's what I have. And I'm happy to answer any questions or criticism or whatever.
I was just wondering, one of the use cases is mitigation. So, with the curl example, right? You have the curl project and I'm sorry, it's not louder yesterday. But like, so the curl implementation in Debian would be different than the curl implementation in Ubuntu. And so they might have different CVSS scoring because of mitigations, things like that. How does that get captured in OpenVEX?
It doesn't. OpenVEX doesn't deal with scoring at all. We've had some folks asking if VEX could be used to change scores. For example, like if a company determines that a CV is less risky to them, use VEX to downplay that. But it doesn't do that. It doesn't do that. It's just about the impact.
Thanks, Adolfo. So I would like to continue this question. So now, in your opinion, is it useful to combine all of those different VEX history together to know all of those different statuses provided by different maintainers from different ecosystems if you don't know what is the different impact to them? From the end user perspective, I don't need to know. I just need to know what is my source, who delivered to me, what is exactly used in my container and what is the impact to my container. For example, it's very, very basic example.
Yeah. So in my view, the very, very end user using the software should never be aware of that there's VEX playing into all of the equation that he got. Like he should be able to take the scanner and just magically work. And why do I think it's useful to enrich the VEX history like that? Because it's going to help all of the participants in the supply chain to make better decisions. For example, in your case, in Red Hat, if you get a signal from upstream that things may not be affected or are affected, you may be able to, produce your own VEX based on a more informed decision from them. And as that vulnerability flows down the chain, it gets enriched even more and more and more. And hopefully there may be a point where we can start trusting the VEX statements based on who is issuing them.
Sorry. Okay. So, but the problem is that from the scanning vendor perspective, having more information, yeah, it's nice. But at the same time, if I have now 5 different statuses, 2 of them are affected, 4 are not affected, and 1 is under investigation, which one is correct?
Exactly. And each piece. So one of the big discussions what we had in VEX in the beginning is VEX transient? So if my upstream component issues a VEX document, can I just ingest it like that? And the answer is no, because you need to do some assessment before you ingest it. And yes, there may be conflicting statements upstream, but the idea is, remember when I was talking about proof of inclusion of others' opinions into your VEX change? The idea is, if I, for example, I'm Red Hat and I issue like a VEX statement saying this is not affected, you can also back that statement by like referencing the previous statements, like this is not affected. Why? Because me did the assessment, but also Daniel Stenberg made it, and also the researcher maybe found out about that. So that's where I see the value of a really rich VEX history, because it's not just one person saying. Because if you think about security scanners, like open source is really at the hands of the scanners and the databases, and like the open source maintainers sometimes do not get a voice in that. And what we want to enable is that flow of information should all complement each other to give you the best outlook possible.
Okay, thank you.
I think continuing to build on that, and I think you kind of just answered it, but I'm still left with the question of, so are the documents linked to each other in any way, right? To kind of the point, right? If I find a vulnerability in a product, right, and I create a VEX document for it, and then independently, Tyler finds one the next day and he creates one, right? And then are our 2 linked together at all, or no?
Yeah, it depends on 2 things. Basically, so those are 2 VEX histories separate, right? And you want to combine those into one that may be happening inside of a VEX processor, your scanner, for example.
Sure.
So if your scanner takes a look at your statement and at his statement, then it may be able to combine them.
Sure.
But ultimately, you need to have some sort of policy on what gets recognized to flow into that. And that's where the trust model goes in.
Okay, that makes sense. So the follow-up question that I have is more of a thought experiment, right? What stops the identifier, right? You mentioned that that one of the where is it at here? One of the things, right, is the identifier. What stops my identifier from being slightly different than Tyler's to the point where the scanners wouldn't be able to identify that we're talking about the same thing? Is there some sort of standardized format or like a backend database of so basically we run into this problem with like manufacturers, for example. I'll just use that, and then you're more knowledgeable on this than I am, right? So one person types out Schneider Electric, another one types SE, right? And how do we solve that same problem here, where we're talking about the same thing, but 2 different people are typing it out slightly differently?
Yeah. So the answer is 2 ways. One, this is what I was mentioning in the beginning. We only act on the artifact level. So a package URL can point to a specific piece of software, like this is a curl version, whatever architecture, whatever from Debian, like it's a specific package release, and always preferring also hashes. So this is the hash that I'm talking about. And the other one is we try to control divergence of that interpretation of the identifiers by handling the parsing ourselves. So if you build a VEX processor, you pull our libraries and they will resolve the identifiers, and so that everything behaves kind of the same way.
Thanks for the talk, and nice to finally see you in person, Adolfo. So 2 questions, right? When I think about VEX, immediately I think about SBOMs. I know the two aren't necessarily tied together, but we use SBOMs to assess third-party vendors or potential acquisitions, right? Now, you might be looking at an SBOM with thousands of components. So, back to the question of, what if there's a discrepancy? If I have an SBOM with thousands of components with hundreds of CVEs, I don't have time to look through that VEX information, right? So one question is, is there a plan to incorporate VEX back to the vulnerability source? I get the scanners, but I'm not assessing an SBOM with a vulnerability scanner. I'm assessing an SBOM with dependency track as an example, and I'll talk to you later about SPDX. So I think that's the best place to push VEX or OpenVEX information, because if MVD doesn't have it, or OSV, or GitHub advisories, whatever it may be, it's going to be harder to assess SBOMs for the VEX information that we need.
Yeah, well, it's one thing that we need to consider here is that you will be, I mean, this wasn't like a example with curl because it's kind of well known, but most of the time, those VEX statements are going to be talking about software, which is pulling the dependencies where the vulnerability is located. So in this example, we were vexing a container image, and the CVE record for that imaginary CVE is going to be inside, is going to be associated to the curl, not to the image. So the impact is, so you take the vulnerability existing in curl and then you assess it to your product, and your product may not be listed on the databases. I don't know if that answers the question. Oh, okay.
Hi, thank you for the talk over here. We're good. Thank you for the talk. Appreciate it, and always big on open source community and collaboration. Similar thread in prioritization and some of the scoring changes that were talked about. And I know you said we're not changing the score, but we are talking about how do you respond to it and which ones do you prioritize first? Which ones are the biggest threats, facing you at the moment? Part of that requires threat intelligence. And so will VEX be having a threat intelligence integration module, or are there collaboration with partnership orgs that we should be looking at when combining these thought processes together?
Well, it's nothing we had thought about, but at some point, why not?
Yeah, I was a few minutes too late, so I apologize if you made that point already in the beginning of the presentation. What is unclear to me is regarding the researcher's VEX statement. To me, there is no sense at all to have a researcher made a separate VEX statement, because to me, it would just complicate the situation. I would expect that the researcher directly collaborates with the maintainers, and there is a consolidated statements out of that, because at the end, this process is somehow then complicated. And at the end, I also don't care who reported what. I want to know the facts of the bug, of the vulnerability, and the associated statement. So regardless whether researcher A, B, or myself as a maintainer has found it.
Yeah. I mean, so researcher can fit many different personas. So there's like, for example, there's people researching vulnerabilities that are legitimate, are disclosed in coordination with the open source projects, and they may not be issuing VEX documents, but that information flows into the databases, kicking off a new possible VEX history. That's a good standard. Then there's the researchers that do that independently of the project. That's another one. But there's also things like, for example, software auditors, right? If you're controlling, for example, your releases, let's say that you have a policy that blocks any release with vulnerabilities, you can automate that using VEX. Like, okay, I know that there's a vulnerability, but I know it doesn't impact me. I VEX it, of course, a release. You may be able to do some automation from third-party auditors, like looking at your code. And if you offload that those assessments to a third party, they may be able to issue VEX documents, which if you properly authenticated, you may be able to let them flow into your VEX history and let the releases go on. Same thing with automated tools, for example.
Hey, thank you for the talk. It was great. You mentioned that the OpenVEX statements will track effectiveness at the artifact level, but sometimes an artifact being included in a product determines whether it's affected or not. Is there any plan for that? Because you've shown OpenVEX statements produced by vendors, and the vendors may indicate that, for example, I'll use Red Hat. OpenSSL within RHEL is affected, but OpenSSL within OpenShift is not affected. And the Perl for both of those components is the same, unless you use like some custom qualifiers. But I don't know how that would look in the OpenVEX statement.
Yeah, that's a really good question. Yeah, so if I understood correctly, the question is, I deploy OpenSSL in one environment or in the other, and this one becomes is affected and the other one isn't.
Yeah.
So the idea here is the VEX product is, in this case, OpenShift, or what was the other one, RHEL?
Yeah, RHEL.
Exactly. So I can, VEX should be talking about a container image of one of the images of OpenShift, right? The statement, the product of the statement would be the image, and then you can issue a different VEX statement for the image based on RHEL. And that gives you different outcomes, because it's not, the products don't have any meaning, like product commercial families of products, it's just about the artifact. So you have an image, this one is affected. You generate a new image, you need a new VEX statement for that one.
Okay, but the container image may not be the deployment artifact itself. Like on RHEL, it's an RPM within the OS, right? And then in OpenShift, it's an RPM installed in a container image that becomes the product itself.
Yeah, so if but the VEX is about the product of the VEX statement is the image, not the RPM. Just as the example with the image and the Debian curl.
Mm-hmm. Okay, thank you.
All right, we've got about 4 minutes left, so this will probably be the last question, I think.
Hi. So I guess my question is that a lot of products will compile their own binaries from source. And I guess, how would you see OpenVEX kind of accommodating that workflow? So, take the curl example, what if somebody takes their own copy of the source code and compiles it for their own usage? Does OpenVEX, is there a way that it could be accommodated, or I don't know what the word would be.
So you can always point OpenVEX at the specific release. You can even craft to the commit hash if you want. Things are becoming more and more edge cases. So right now, the proofs of concept that we have, or actual uses, are on the package level. So things that can be that are already built and can be named as such. There's nothing potentially and semantically stopping you from doing a VEX for source, but then there are tons of things that can happen from that example, from that point until it gets deployed, that I don't know how useful it would be. It would be interesting to research.
Yeah, I don't know if there's a lot of examples, but maybe different compiler, implementations might do something.
Yeah, sometimes a flag can trigger a vulnerability, for example.
So, thank you.
All right, folks. Well, thank you. This was a fantastic talk. Clearly, everyone is very engaged. We've got lots of really good questions. So thank you again.
Thank you very much.